Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility, with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
If I was to say, where is air traffic management next generation? It's decentralized traffic control situations, contract towers, increased automation, increased volume of aircraft, ubiquitous to who the user is for the aircraft, and ubiquitous to the mission of what that aircraft is flying, with greater awareness and greater interoperability. That is, I think, a successful roadmap to safe integration of the airspace.
Hey everyone, welcome back to The Vertical Space. Today we're taking a look into the future of air traffic management with Chris Hewlett, a retired naval aviator with 30 years of experience in aviation operations, safety, modernization, and optimization of next-generation aviation systems. While in the Navy, Chris was involved in modernizing rotary wing manned and unmanned aviation through integration, test, and evaluation of new systems, and that's on top of being a helicopter pilot. Following the Navy, Chris led advanced air mobility drone services for Deloitte Consulting and PricewaterhouseCoopers, providing UAS strategy, application, and analytics to clients across the economy. Chris is currently consulting for Thales USA, developing their newly established UAS traffic management division of Air Mobility Solutions and Air Traffic Management. You can see now why we wanted to talk to Chris about UTM, or Unmanned Aircraft Systems Traffic Management. In the conversation that follows, Chris offers thought-provoking insights on how we as an industry should be thinking about the management of a truly integrated airspace system that's agnostic to the type of user, be it small drones, general aviation, commercial aviation, or military aviation, and also how current approaches to UTM are not quite aligned with this end goal. Chris draws parallels to best practices in the military and talks about the pioneering work being done in North Dakota as part of the Vantis project. Sit back and enjoy the conversation with Chris. This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace. Chris, thank you very much for being a guest in the podcast today. So we're talking about UTM, or Unmanned Aircraft Systems Traffic Management. And there's a lot that we can talk about, but before we jump into the weeds, first thing that we ask our guests typically is there anything that very few in the industry agree with you on?
Yeah, there's a ton of stuff that very few in the industry agree with me on about.
Perhaps as it relates to UTM.
As it relates to UTM, yeah. No, and that's a fair point, right? I think it's the methodology to get from point A to point B. Very few people in this industry feel like there's a circuitous path to success with UAS transportation management. And let me start off by saying, first of all, I appreciate the introduction. Thanks so much. Yes, I do work for Thales. Yes, I do work for a lot of different companies. Everything that we're going to talk about today is solely the view of Chris Hewlett, not attributable to any of the organizations I work with. So these are my thoughts, not anybody else's. And that's to make sure that we're on safe legal ground here. But when it comes to that conversation that you're talking about, Luka, it's interesting, right? The circuitous pathway, that is the success of integration of unmanned systems into the national airspace or anybody's airspace, is the pathway that is in my mind, is the pathway that I think is the road to success. I think most people in the industry, I think most people in the regulatory world are looking at this as a straight line pathway that is sort of a straight line, linear progression of success, trial and error, success, trial and error, success, those kinds of things until implementation. I think we need to think outside of the box. I think we need to be lateral in our thought process. I don't think there is a right answer. I think we have to use all avenues of approach, including rapid prototyping, fail fast, learn from our mistakes, and move on. And that's hard. That's difficult. And it's very, very difficult to lay that out for people to start thinking about, because it has no logical progression, no succession of thought from one thing to the other. You don't go A, B, C. If you look at somebody and go, the only way to get to air traffic management, I'm not saying UAS anymore, but air traffic management for the future of our needs is to go A, 25, pi, sigma. People are going to be like, what does that mean? So I don't know that that is a prevailing attitude in industry or in regulatory world.
Let's take a step back and just talk about UTM at a high level. So can you tell us a little bit of background and where we are today? How did we get here?
Great question. And when I was thinking about how to answer this, it really is the journey of discovery, right? If you look at the concept of interoperability of drones, this is nothing new, especially to those of us who have served in the military. And I know we've got a lot of people who do that, but drones is nothing new, right? We've been using drones in the U.S. military since the 1930s. But the influx of drone technology following 2008 to 2012 and the emergence of the Federal Modernization Reform Act and the implementation and roadmap of integrating unmanned aerial systems into the national airspace really kind of pushed things. And it was a decision point, an inflection point in the technology evolution. And I hearken back to my childhood and think about what are the similar characteristics to things that were transpiring when I was a kid, when things were kind of new and fresh for me. Can you imagine if we went back to the 70s? Remember what was big in the 70s is the remote control cars. Man, I really loved remote control cars. I wanted a remote control car. Everybody wanted a remote control car. What would have it been like if the federal government back in the 70s had made the decision to share our national transportation infrastructure, i.e. the roads, with remote control cars? How much change would have been required by the Federal Transportation Administration, Federal Highway Administration, the Department of Transportation in each state to create a system that was capable of handling both vehicles being driven by people and vehicles being driven by remote people, to aggregate a system of transportation in a two-dimensional fashion? We're not even talking about airspace. Two-dimensional fashion such that we kept lives and property safe in the 70s. And now you fast forward to where we are now, when we made the decision to implement this process and to work from a federal perspective of democratizing the airspace such that it is ubiquitous to the user. General aviation, commercial aviation, military aviation. Now they're calling it unmanned aviation, but I call it autonomous aviation or remotely piloted aviation or uncrewed aviation, right? But that system is the thing that people started having the conversation about early in 2012. And then it just gradually started taking on more steam as businesses start to find efficiencies using drones. And that demand signal has pushed the regulatory environment to start turning in on itself to solve for the solution of how do we aggregate airspace for unmanned systems, uncrewed systems, whatever you want to call it. And now we're in this really weird spot. And I say that very intentionally. We're in this very weird spot now because vehicles need to be certified, command and control systems need to be certified, architecture needs to be developed in order to ensure that aircraft are functioning in the right airspace at the right time with the right oversight, communication systems, telecommunications, all of these things, all of these incredible advancements in technology all have to happen simultaneously for us to get to this. If you think about our example that I gave you for the roads, that was back in the 70s, pretty daunting idea to think about. I think this is even worse. And the reason why I say that is because we're asking a whole lot without knowing much. And we want it sooner because we've become an on-demand society, right? We click on a button in the middle of the night and expect it to be on our doorstep in the morning. And if this process is going to play into what is the expectation of our society for the way that drones or integrated airspace is going to service us in a safe an acceptable fashion while still meeting the demand signal that we have, this is a pretty daunting task, right? As we evolve in the conversation, I think it's important for everybody to realize that having an end state goal in mind and understanding that there are limits to what can be done and what should be done is most important. And therefore, figuring out where we are in the journey is probably the hardest thing, because I think even though people are starting to say we're getting closer and closer to this, I think we're actually further and further away from it because we really have never studied this concept before.
Is it an issue of defining what the end goal is? If we say that the end goal should be a streamlined access to the national airspace or other national airspaces, regardless of who you are, an aircraft, an unmanned system, small drone, large drone, doesn't matter. It should be all one system that lets you do that. One, is this the end goal? And if it is, how do we get there in a pragmatic way?
Exactly, right? And you hit the nail on the head of how do we get there? And we'll just start up in life and business. Things are not fair. So accepting the fact that there has to be some type of limits put in place, some type of risk mitigation put in place that is an oversight function that allows the system to mature while being self-limited such that it can have success, it can learn from the minutia of mistakes that happen and not amplify those mistakes into bigger problems, and then still grow such that it can become more accepting of additional technologies, additional resources, and additional capability, seems like the only logical approach. To try and create a completely ubiquitous and completely democratized system that is going to accept everything from 55 pounds and lower small UAS to full-scale Class 5 autonomous drones doesn't seem like it's a completely realistic goal. And to disaggregate that and say what we're going to do is, and I think this is an attitude that was adopted early on in this process, is we're defending the airspace against drones. And that's we're defending airspace instead of saying what we're doing is we're aggregating airspace and creating an interoperability, a more friendly environment in which aviation can operate safely. So instead of trying to take a small bite out of the apple, we've decided to consume a bushel of apples, like immediately.
So what, in your view, what is the end goal?
The end goal is, realistically speaking, is if we say that, this country, and I'm not speaking for anybody else's country, but if the United States of America is driven by business, and we are a profit before patriotism country, that there is no denying that, right? If we are driven by business, and business needs are such that there's efficiencies from using unmanned systems, uncrewed systems, or some type of drone, it would be unconstitutionally sound to say that you would be limiting any use case that anybody's coming up with for a drone. Therefore, the only logical way forward is a fully aggregated system that allows autonomous, uncrewed, general aviation, commercial aviation, and military aviation to operate within our airspace. And if that's the case, that's that whole bushel of apples I just mentioned. And figuring out how to get there is really where everybody's sort of stymied right now.
What are some of the key issues that we're facing to get there?
It's architecture design. It's literally who owns the airspace, right? So at this particular point, there is no appetite inside the federal government to adjudicate or govern or manage 400 feet and below. So that in and of itself is a question mark in my mind and a question mark in a lot of people's minds. So how do you create an architecture that's fair and equivalent between states when the states are being told, and not just at the state level, even at the county level, they're being told to manage the problem themselves. So you look at places where you have large cities on the border of states, and you have two different states who have adjudication over their transportation system. How does interstate commerce operate in those worlds where the drone is probably being told it can be limited to utilization in one particular way in this state, and the neighboring state, which is right next door, has a different architecture? So because it's not that there's no federal oversight, there's just no federal interest right now to figure out what that architecture looks like. So it's evolving, as all things do, simply because it has to. And so state and local agencies are doing their very best with air navigation service providers and supplemental service providers and all the various different entities that are coming into the state to try and make it work, but they're not growing in concert with one another. And so that creates disaggregation and confusion and slows the process down, and then also runs the risk of spending a lot of resources and time when unfortunately the federal government may step in later on and say, well, now that this is growing beyond what we thought it was going to be, we're going to take it back and put some controls in place.
So could you just, for our listeners, just define who are the big players and how has it evolved over the last 10 years?
So transportation management, so air traffic management, ATM, and then UAS transportation management, UTM, which means something very different if you're in Europe. Here in the United States of America, it's unmanned aerial systems transportation management. It's the governing and command and control and mitigation risk and flight planning for unmanned aerial systems, drones. In Europe, for EASA, UAS transportation management means that the transportation management or air traffic management system is got automation and digitization applied to it such that you reduce the amount of manpower to actually run the air traffic management system. The reason why those two things are so important to say is there's a harmony that's supposed to exist between Europe and the United States about the way air traffic management works and the way the federal agencies that govern that air traffic management works. In the future, at some point, if there's ever a discord between the two of them, we have to harmonize it, is what it's called. But the reality of the circumstances is the Europeans have been very pragmatic about this. They're looking at air transportation management like 2.0, 4.0 kind of thing, where they're like, look, all of the air vehicles and everything else like that, they'll get to autonomy, they'll get this and the other. We have to get the traffic management scheme the right way. And to them, it's all about digitization and computer powers and getting processing done the right way. Here in the United States of America, we have a labor union that's associated with air traffic management. And I'm not blaming the Air Traffic Controllers Association for where we are, but it's part and parcel of the conversation, because you can't have a tangible conversation in the United States of America about replacing air traffic controllers with artificial intelligence or machine learning. That is not going to be supportive in our traffic management conversations. So people have steered away from that, rightfully so, because it's a labor union, right? We don't want to upset the cart here. But because they've steered away from it, it's gotten into a conversation around air navigation service providers who are creating routes and deconflicting. And again, it's all based on defense of the airspace instead of commingling and co-utilization of the airspace. So you can see the disparity in the way UTM is evolving, because it means something very different in Europe than it does here in the United States.
So then as you define UTM, you talk about the differences, and Lucas talked about, what is the end state? How would you design UTM? What is the ideal? And how should it evolve over the next 5 years? And what's the FAA and NASA and others doing to make it happen?
Right. So first of all, let me just throw a plug out for NASA and the FAA. Absolutely doing the lion's share of collaboration and coordination with communities to ensure that this is going in the right direction. I am in no way throwing the federal agencies under the bus. They have constraints that they have to operate under, and it's very daunting for them. So nothing that I'm saying is being critical of FAA or NASA. They're doing a phenomenal job given the pressure that is involved in this. Mm-hmm. Where should UTM go? I think it's a blended approach between what the Europeans are looking at and what we're looking at. I do think there's a level of automation and machine learning that needs to come into play, simply given this. Okay, if I start to say, what's the baseline for air traffic management of the future? Take the U out of this and just talk about air traffic management. Because if we look at an airspace, any volume of airspace, and say that the general aviation enthusiast is always going to want to fly their Piper Cub. They're going to want to go out and they're going to want to feel like they have access to the airspace. And that's what they pay their taxes for, right? We shouldn't say no to them. Businesses that operate commercial aviation, 121 and 135 certificate holders. That's, these large companies that deliver packages and people in a traditional sense. they're going to want to have their ability to keep doing business, and we shouldn't tell them no. The military is always going to have access to the airspace, and you can't tell them no, and they operate unmanned systems or uncrewed systems as well. And then you look at this emerging group of operators, whether it's small mom and pop or large Fortune 50 companies that are going to start operating uncrewed systems or autonomous systems. So there's not going to be an opportunity in this to look at any one of those segments of the population of airspace users and say, you don't get to do something. That's not a fair statement to make reasonably. So if that's the case, then they have to be able to interoperate. And if they have to be able to interoperate, you're talking about several orders of magnitude higher air traffic in one confined airspace. The answer when the labor unions are brought into the conversation cannot be, we're simply just going to hire more bodies. Even the best human being can't effectively manage that increase in volume. So yes, I think it's a blended approach. We will have to hire more bodies, but those bodies are going to have to rely on increased capacity of computing power and digitization and automation in order to ensure that the human in the loop is being used most effectively, and that the computers can do some things that right now are probably not necessarily required. That growth in the airspace is going to add jobs, increase capacity, and create a situation that everybody's going to be much happier with. But right now, I think that is the fundamental problem in the conversation, is those things are diametrically opposed. There's this conversation about we need to digitize, automate, and reduce the human in the loop. Once the volume of traffic goes up, we need to increase the human in the loop capacity to increase safety and mitigate risk. So if I was to say where is, air traffic management next generation, it's decentralized traffic control situations, contract towers, increased automation, increased volume of aircraft, ubiquitous to who the user is for the aircraft, and ubiquitous to the mission of what that aircraft is flying, with greater awareness and greater interoperability. That is, I think, a successful roadmap to safe integration of the airspace.
So according to the FAA, UTM is supposed to be a community-based traffic management system where information is shared and data is exchanged not between pilots and air traffic controllers speaking on the radio, but through APIs, through a distributed information network. And all of the actors, all of the stakeholders involved in the flying operations are supposed to, or actually are responsible for their own coordination and management of these operations. What would traditional ATM look like if it adopted that same mantra? And do you think that when we're talking about UTM, we really should be fixing ATM to make it in that image?
Yeah, so those are two quick questions. I'm going to address the last one first. Absolutely, UTM should force us to wake up and fix ATM, which is why I keep going back to my statement of saying I'm not going to use UTM anymore. It's just it's because it's not unmanned, and it's not an unmanned aerial system with people in the back of it. An e-taxi is not unmanned, and I think air traffic management just needs to graduate to that next level. But your statement of what would air traffic management look like if we were talking about it, the only thing that I can say is anything similar to what that would look like would be Hurricane Katrina here in this country. And as a helicopter pilot, I was involved in the rescue efforts of Hurricane Katrina, which was a hornet's nest of helicopters in what's traditional MARSA role, military see and avoid. And we did not have any air traffic control oversight, and everybody was flying around low to the ground. So even the AWACS and the E2s that they had airborne could not see the volume of helicopters because of the radar clutter and the pulse width masking close to the ground. So the reality is, it was our job to find people, rescue people, and not hit each other. Now, we didn't have one single midair in the 2 weeks that we did rescue efforts in New Orleans. And when I say there was a lot of helicopters, there were a lot of helicopters, and they were all from different agencies: Coast Guard, Marine Corps, Army, Navy, Air Force. Everybody was there, even civilian helicopters, and nobody hit each other. But the volume of work that was put on the pilots, I mean, we were flying unbelievable number of hours on top of the fact that we were constantly on a knife's edge because we were going to run into somebody else in the process of trying to rescue people. That's not a sustainable air traffic management scheme, which is what you described when you say community-based awareness. which is the responsibility of the operators to say, here's where I am, here's where I'm going, and let's deconflict between you and me. If we were to graduate that to Air Traffic Management 4.0 and tell everybody who has a 121, 135 certificate and somebody out there just joyriding around to see and avoid and make sure things don't go wrong, that's setting ourselves up for failure. And failure in the aviation world usually spells disaster.
Tell us about, if you were king for a day, what would you design? What would be your top priorities as it relates to UTM to make sure we have a safety first, efficient airspace?
I think we're doing a great job, first of all, given the constraints that we have, as you mentioned. But what we've done is we've looked at various different states and said, hey, let's do some integrated pilot programs. Let's try Beyond over here. Let's start working on BV loss here. Let's start bringing in ANSPs who are businesses and they want to sell their product, even though it's not a complete product. And a lot of them have started up and shut down, started up a different one and shut down. They've all got different constructs for it. What we haven't done, what I haven't seen, and what I would try as king for a day, and as the king, you always get criticized, but this would be what I would do. I really liked what the automakers did up in Michigan. I thought when they put together a city completely designed around electrification to drive cars on a track for hours and hours and hours and interoperate and test and interoperate and test and do various different fail safes. What's wrong with the idea of doing that in various different places? And I understand that there's a competition factor, right? You want to bring out the best and give industry a chance to try and create some type of forward-leaning process that you can capitalize on. That's great. But to me, that's not where you do your test and evaluation. I think the standards for what industry needs to adhere to, we don't have a test facility to actually generate those standards. To say, whatever you do, don't use 30 hertz, because this is the problem we see with 30 hertz for the CNSI structure. Whatever you do, don't use this code because we see a problem with it. We're not telling industry what to do, but so far industry has been left to figure it out on their own, and they're great. They're amazing. They have a tremendous capability to expand and grow. The problem is you can't pick a winner. You have no idea which system is going to work, fully aggregated or not. So at that particular point, I'm wondering, wouldn't it be better if we just figure out what the standards are, publish those, and then let industry say, oh, okay, we'll start building our product around those standards, instead of letting industry build standards and then us trying to figure out whether or not those standards will work for certification process. It seems a little backwards to me.
So do we need a globally standardized approach to UTM? And who sets that standard?
If we need a globally standardized approach to UTM, it's only because we want to make sure that transnational commerce will work. In North America, if our transportation management system doesn't cooperate with Canada and Mexico, that's a fail, right? If I can't take something autonomously and get it from a point of origin in the United States to a point of arrival in Canada or reverse, then that's not a good business model. And companies will get upset at us for that. So I would suggest to you that yes, there needs to be some type of international standard or cooperative application program interface that allows the systems to exchange aircraft in flight the same way that we do with air traffic control right now, because they've got their own separate air traffic control system under NATS in the UK. It's privatized, right? They don't have the Air Traffic Controllers Association like we do. But nonetheless, they managed to get an aircraft to take off from the UK and fly all the way over here to the United States, and there's a seamless interaction between the two. So why can't our transportation management of the future that incorporates all modes of travel for aviation be the same thing? Or why shouldn't it be, I guess?
How is UTM done today by sophisticated drone operators?
I'm gonna pick at that question. What is a sophisticated drone operator?
Good point. Without naming companies, there are operations that do drone delivery at some decent scale. There are certain operations that do small package delivery beyond visual line of sight.
That's not transportation management. That's transportation awareness. There's no manager of the air traffic.
Right, but they act as their own USS in that case.
Yeah, it's not air traffic management. It's not even really great air traffic awareness, because the reality is they're segregated into 400 feet and below. And the only reality of that circumstance is there's a Lance process that provides some level of feedback to FAA to let them know that there is a drone operating in an area somewhere. But that's like I said, it's just awareness. It's ATA, air traffic awareness. But the management piece, that's self-managing. And so if it's self-managing, is that really managing? Because you're taking into account that the person who's operating the drone actually knows what they're doing.
The activities that are ongoing at Vantis, and perhaps you can say a couple words on Vantis, how does that relate to UTM?
Yeah. So again, when I alluded to the test environment, and Vantis is a great case, right? As it starts to build out a transportation management network for the state of North Dakota, who was a lot of people know that North Dakota is one of the leading places for aviation in the world. More pilots are trained in North Dakota than anywhere else. And it's because they have such a great working relationship with the airport, the Federal Aviation Administration, and the university there. But at the Vantis network, working in collaboration with the Northern Plains UAS test site and Grand Sky up there, has created this microcosm that is capable of expanding operations and bringing in people who can start operating. I mean, there's some very heavy hitting big OEM companies that are operating up there using the network of beyond visual line of sight capability that Vantis and some of the integrated services provide. And it's becoming a model that even, the U.S. Air Force, because all of that's co-located at the Grand Forks Air Force Base. There's a privatized side and the actual Air Force side. But even the Air Force is starting to take notice of this because, alluding back to what the military does, it's not uncommon for military to operate uncrewed and crewed aircraft in the same airspace over the horizon in theater, right? That's the way it's done, without getting into too much detail and saying anything I shouldn't. But the reality is that the Air Force would love to be able to figure out how to do that here in the United States of America. Well, it's already starting to happen up there in Grand Forks Air Force Base because of Vantis, because of the interoperability with the Northern Plains UAS test site and Grand Sky, which is the tenant facility that everything lives on up there. And companies are now starting to see that avenue of approach. And it's been interesting to have the conversation with them because they're not asking for anything other than the opportunity to come up there and just perform sustainability and operations to gain information and data to be able to push through the certification process. So the circuitous path that I was talking about taking, this is the circuitous path. It's not necessarily commercial. It's not necessarily military. It's not necessarily public entity. It's a conglomerated joint venture around a single area that has the resources and the capability to allow test and evaluation to proceed with a mitigation towards risk and the eye on safety. And once you can aggregate the data from that, you can now start to tangibly get your hands on what a model could look like that does transportation management next generation. And I think that's the interesting conversation that where NASA and FAA want to be involved in next steps. It's, hey, we deployed these radars and these telecommunication systems and these ADSBs and and plugged it all into the system. And were we doing better or were we doing worse? Was it the same? Was there value added? Those are the questions that I think are getting answered up in North Dakota. And I think where everybody's starting to have a really tangible conversation about crafting what the future of air traffic management is going to look like.
And how does the experience at Vantis shape your views on the scalability of the UTM?
It actually provided me with a tremendous amount of faith because originally around the traffic management scheme about air navigation service providers was reliant on, the remote pilots and the drone operators and even the companies that were operating at scale, the drones, providing information to the ANSPs who then provided it to FAA, who then provided it to each of the ANSPs and did all the route deconfliction and everything else like that. What's going on with Vantis that I think is very unique is it's an incorporation of several things. Existing infrastructure, and when I say infrastructure, I mean hardcore radars, ADSBs, comm suites, those kinds of things that are already in place inside the state, and then building on top of that capability with additional infrastructure where companies are coming in and putting additional awareness capability, whether it's radar or ADSB or comm suites or any of that stuff. They put all of that in the ground to create an overlap and the ability to have enhanced awareness and then aggregate all the data and start feeding the data into a true CNSI architecture where it's command, navigation, information exchange, and surveillance all happening simultaneously at one point. And then you can then bolt on supplemental service providers, ANSPs, whatever you want to do for the microcosms throughout the state. So if you create in the Vantis world, what North Dakota is looking at is a network of information exchange and systems that are aggregated throughout the state such that when you're in a large rural area with nothing to fly over and no one to hit, you have minimum oversight and minimum requirements for feedback and information between the air vehicle and the network. And then when you're in a more urbanized environment with a higher density population and more things to run into and more things to be separated from, you have a greater amount of oversight. That's a scalable and manageable architecture that I can take from a place like North Dakota and move it to another place, another state, or another city and start building its unique capability based on the lessons learned that we had in the state of North Dakota.
And to what extent is the infrastructure extensible and independent of the particular use cases of the operators?
Well, see, that's the interesting statement, right? And I love the fact that you asked that because it is ubiquitous to use case. I really don't care what you're using it for. I don't care if you're using it for spraying crops with drones that are used for agrarian purposes. I don't care if it's package delivery. I don't care if it's a military operation. It's literally just information exchange and data aggregation. And so as you create the network, it's all based on service volume and not based on business cases. So if you're going to open up a distribution facility for logistics purposes in and around the city of Grand Forks, right now would be a great opportunity to do that and start testing out capability to be able to do scalable deliveries to areas. Now, whether or not that's a good business case, I have no idea. I don't know if it's worth it to be able to deliver via small or smaller UAS at scale. Somebody's going to have to figure that one out. But I can tell you that if you add that volume of aircraft into Grand Forks right now, the system is capable of handling it. Mm-hmm. And that to me is the most interesting thing.
And who's managing the information exchange? I mean, is there an authority that's in charge of this, or is it completely decentralized?
No, it's a state authority. So Vantis is actually owned by the state of North Dakota in conjunction with Northern Plains UAS Test Site. It's a public-private partnership, which is actually a phenomenal way of thinking about moving forward, mm-hmm. because the state, no different than your road system, has interest in the infrastructure around distribution, right? So if this was completely privatized, the oversight would be very confusing. Mm-hmm. But this is also being done in concert with oversight from the Federal Aviation Administration. The regional administrator is plugged in on it. And again, this is happening at 400 feet and below. So right now, as is stated by the Federal Aviation Administration, they're hands off. But the level of awareness in Grand Forks in that area around North Dakota and North Dakota as a state at large is growing exponentially for the Federal Aviation Administration, which allows them now to start making logical progression towards the next step of air traffic management and see the amount of information exchange that they're dealing with. Again, it's not trying to create the cake right away and say, here you go, and then have mm-hmm. everybody go, well, we wanted chocolate. That's vanilla. That's terrible.
So Chris, how should UTM be monetized?
Oh, okay. So great question. I've already laid out like everything around the public-private partnership that exists that's growing in the state of North Dakota. I think that's a beautiful way for monetization. What that allows is, if you think about the way toll roads work, it's you pay to use it, right? The state invests in it, and then there's a certain return on investment for the better good of the state. So we want to build a connected corridor between this city and this city, or this area and this area, and we hire a large-scale company to come in and do this capital project for us, and we're going to lay all the money out out, but we need to recoup that money. So all the people who want to use that corridor end up paying a nominal fee or whatever fee it is over a course of time that pays the state back for all the infrastructure they put in place. And then usually when those toll roads, and I think about the bridge that goes out to Coronado, out to North Island in San Diego, that was a toll bridge. And now that it's been paid for and the state doesn't have a debt on it anymore, you just drive back and forth. So that's the concept behind this public-private partnership schema, which is to say, hey, there's a demand signal here in the state. We would like to have this, and the citizens of the state would like it to grow in concert with their needs, and they're willing to pay for it. So there's some amount of it that's coming from the taxpayers of the state, and then there's some amount of the investment that's going into it from an architecture perspective as far as who's building on the infrastructure. The expansion, and the only other example I can use is the expansion of telecommunications within the United States of America. A lot of people don't realize that the various different cell phone providers, they don't actually own the architecture. They don't own the infrastructure of cell tower. They rent space on a cell tower in order to put their transceivers on. And the owners of the infrastructure a long time ago figured out, hey, this thing called telecommunications, this is going to be big. We're going to buy land places and we're going to put big towers out there and we're going to eventually hang stuff off them. Well, that came to fruition, and that's how they make their money. So we don't realize it, most people don't realize it, that when you pay for your cell phone bill, part of that bill goes to pay back the infrastructure providers for putting the infrastructure in the ground in the first place so that you can use the network. That is the model for transportation management at the next level that incorporates autonomous vehicles and unmanned or uncrewed vehicles flying around in our infrastructure that are using the network. And it makes sense because there's always a downstream component of cost that's pushed down in any kind of supply chain. But if you want your toothpaste or toothbrush in the middle of the night delivered to you by drone or uncrewed system, and you're willing to pay $100 for it, part of that $100 goes to pay down the infrastructure on the network and generate a profit for the companies that were involved and the state that was involved in creating it.
Let's say you're going to invest in this model that North Dakota has created. Let's say it's scaled across the U.S. What technologies would you invest in that you think will be most required for this kind of system? And what kinds of companies are doing that today?
As far as investments, that's a great question. I would invest in companies that make radars, ADSBs, comm suites, and who have systems architecture designed around information exchange. That is probably the most prevalent thing that's gonna end up taking over. I'm not sure. There are some people who are saying 5G is the next way to go with this, but I'm not quite sure that 5G will meet the needs of what's required from a low latency perspective around aviation. Not 100% on that one. So, but there are a number of people who are talking about it. But who are the companies to invest in and who's doing this? It's the traditional OEMs. And Luca and I had been talking about this a while ago. It's not just them. It's also the up and coming non-traditional OEMs who are building new technology. There's got to be some aggregated growth. Old school meets new school in the most real way and comes up with the solution. And I think we're starting to see that as industry is starting to move in that direction. And it's also good in a smart investment strategy to invest in an up-and-coming company that gets acquired by a traditional OEM for their technology.
Without mentioning any names, but what are some of the examples that you've seen in at least in the startup ecosystem of good and perhaps failed business models around trying to monetize UTM?
Yeah, so I'll start with the bad. I think the failed one that comes to mind is when you have a large Fortune 500 company that decides that because it has a name that's associated with aviation, that it's going to stand something up, and it creates a business process, and then the technology it pushes out is really not any different than anybody else's, but I think the hope in it, and I don't ever consider hope a strategy, was that because of the name, that would generate all the business. I don't think that's a great business model. I think when you have a traditional company that steps in, that has a core competency, that actually can work in partnership with the emerging technology side of the house, that's where I'm seeing a tremendous amount of success. That is, one of the companies I work with and for right now is that's how they're doing. They're sticking to their core competency. Hey, this is what we make. We make and manufacture this thing. It's radars, it's ADSBs, it's these kinds of stuff. But when it comes to the aggregation and the application program interface and the design function of figuring out how to do that, we have a little bit of that. But now we'd like to lean in with some of these emerging technology companies and really figure out what's next so that we can bring in new thought around artificial intelligence and machine learning. We can look at new types of displays. We can look at new types of systems aggregation and figure out how do we take the legacy stuff that we know we need and apply it to the future vision and future aggregation items of technology that we know we need to develop and move forward. That is, to me, where I'm seeing success around these businesses.
Hey, Jim, unless you have any other questions on this topic, I'd like to ask Chris about the military, how the military UAS experience shaped views on UTM.
Yeah, no, and that's a great question because it doesn't matter where we go in these conversations. I'm very fond of looking at people going, this is nothing new. And none of this is new, really, realistically speaking. We've been doing this for a long time from an aviation perspective, especially when it comes to uncrewed or unmanned. And when I was doing what I was doing in Southern California with Fire Scout, there was a lot of consternation, especially around the Federal Aviation Administration world, because it was close to Lindbergh airspace, and San Diego County itself is very, very congested and busy airspace. But once you start working through the mitigation and the safety and generate the awareness, it's no different than any other schema of air traffic management. You start calming nerves, you start helping people understand there are limitations, and you start defining roles and responsibilities and left, right, lateral limits, right? Those constraints and restraints, things I must do, things I can't do. And that's where I feel like the military is so far ahead of the commercial industries when it comes to transportation management. They have a well-defined process of what you can do and what you can't do. And when you get into a situation, especially in the Navy, when you're flying, you know what you can't. You know 100% of what you can't do. Everything else is advisory in nature. And so it evolves faster because it can use that I'm going to take some artistic license here with how I'm flying, what I'm doing in order to get the job done. And, like I mentioned, Hurricane Katrina, we threw the rule book out around Hurricane Katrina because the lives of human beings were at stake. So, your traditional limits that you say you can't operate under, those become nice to know limits. And sometimes you had to violate them in order to save lives, and it's acceptable. So if the military can flex to those things, it would be neat to see those things in the test and evaluation process really take on shape around the emergence of industry in those directions, and give them the latitude in the test and evaluation process to have a broader perspective, understand limits better.
I think the military still uses procedural and temporal and altitude deconfliction with UAS systems, but in a complex battlefield of the future, the concept of the system architecture that's designed around information exchange and deconfliction and getting the human out of the loop in the interest of scale. Do those systems exist now in the military, to your knowledge, and that you can speak to? And who is developing these systems, and why are they not, or are they part of the UTM conversation?
So I'll answer the last question first. No, they are not part of the UTM conversation because they are military grade, and I would say that they're, for the lack of a better purpose, they're items of national security. So that's not going to be publicly available. Now, what's being done in the military? I've been out for a little while, but I know that there's a lot of forward-leaning stuff going on. A lot of it is being done specifically around enhanced awareness and battle space management. And I think some of the new technologies are specifically focused on that. But again, we're in a good place because several years ago, I want to say 2014 to 2016, the military acquisition process started moving towards rapid prototyping and really trying to find commercial off-the-shelf solutions. So I think we're a lot closer now to the situation where the military is taking commercial off-the-shelf products figuring out how best to use it, adding the classification level that they need to, and therefore slightly modifying it. But the core component that you're talking about is still available for industry to take and apply in this traffic management scheme to be able to say, hey, this is in a much more plussed up and secret kind of way, really working for the military, but it has great civilian applications. And I think a lot of companies are starting to realize that they can do that, right? They can grow it in the microcosm. So like, here's a great example. And I know we're not talking about specific aircraft, but if you think about it, what Bell and Leonardo did, they built the Osprey, right? Phenomenal tilt rotor aircraft, millions of hours of usage now. But even through the FAA certification process, when Leonardo built the 609, which is a tilt rotor used for 121 operations, 135 operations, they got to certification standards faster because it's just a scaled down version of the Osprey. And that's a smart way of doing business when you say, I've got all the specifications on this and all of the time into this, and all I did was just make it half size or a third size of what that thing is. It's the same exact aircraft. Makes it easier for FAA to say, yeah, you know what, that works. So if we've got things that are operating overseas or in various different places that create an architecture of transportation management that, from a functional perspective, give their credence to the technology that's being involved in it, that allows us to adopt that technology in the civilian architecture and move to a rapid certification process, I'm all for that. I think that's a brilliant idea.
All right. Well, Chris, this has been an excellent conversation so far. Let's try to wrap it up a little bit now. One of the questions that I'd like to ask is, what advice would you give to someone who wants to start a business around UTM? What are some of the remaining challenges for entrepreneurs to go out and solve, either technical or otherwise?
Yeah, no, great question. I would say start getting involved with just your local government. I think there's a misperception that the people who want to be entrepreneurs in this space have to figure out the solution by themselves and then create a solution and then sell the solution. Whereas it's a much better process to go in with the people who are working towards the transportation infrastructure of your state, of your local government, and start finding mechanisms to incorporate their needs and their desires and their wishes for the future of traffic management, such that when you develop your technology and your implementation process, it's working in concert with them. And it also allows them to understand how you're going to grow it, how you're going to operate it, how you're going to monetize it, and therefore feed the money back into their process of trying to acquire funding to be able to support you. It's a hand-in-hand process. And I think what's happening is the air navigation service providers are going out and they're no different than some of the drone service providers, which is desperately a hammer looking for a nail. And that's not a sustainable process, and it creates a tremendous amount of strain financially to the companies that invest in them and to the individuals who are operating them.
If you fast forward 5 years and then 10 years, what does the industry look like?
I think you have a hub and spoke methodology, very similar to telecommunications in 5 years, which is states and neighboring counties to the states like North Dakota with integrated network of transportation management around autonomous and unmanned systems working in concert with even ground networks. And as everybody starts to realize that is the pathway forward, they start developing pockets of UTM, for lack of a better term, but this air traffic management next generation in various different areas throughout the country. And as those pockets grow, the only thing that needs to be done seamlessly, and you'll see this successful in some places and not in others, is making sure that there's a connective tissue between the two pockets of transportation management, such that when the ability to move whatever it is from point A of traffic management to point B of traffic management exists, those things can talk to one another, and therefore that architecture then becomes linked. And so it's very similar to the way the federal road system kind of evolved. Hardball roads didn't just appear overnight. It went from major population density to major population density and then started developing connective tissues from there. Before that, it was all just dirt roads, but even those were based on the higher traveled areas, the people going from point A to point B and slowly causing the erosion. So this growth of transportation management in the US will start in key epicenters. And as people start to learn how those key epicenters work, there'll be areas that are able to connect. And there'll be areas where they fail to connect because of different application architecture. And then they'll take longer to connect. But eventually, that's the way it's going to grow out over the next 5 to 10 years, is pockets of growth that are slowly connected.
So let's say we have an epicenter 10 years from now. We have an epicenter. How much of that technology 10 years from now exists today? That's
a great question. So let me caveat that by saying there's a couple of ways it's going to work. The epicenter that you're talking about, let's call it a highly urbanized epicenter with a tremendous amount of building space and everything else like that. To get all the architecture in place, to be able to have the logistics and the distribution facilities available, it's not simply transportation management. But if you don't grow the vertiport capacity, if you don't grow the throughput capacity for all of the logistics that you're talking about, regardless of what it is, regardless of how it's moving, and the air vehicles simultaneously, most of that UTM stuff already exists today. The other stuff, which is going to come later, is the ability to actually have the air vehicles that it can actually feed into. But the processing capability and the data exchange, I think that's where you're going to spend most of your money on, making sure that the system is fully aggregated, that supplemental service providers and USSs and ANSPs and all of the people who need to back end into the system and what it's being used for and the cybersecurity of that system is where you're going to spend the most amount of your money.
What's the most common misconception around UTM?
That it's, well, for a lack of a better term, that it's up and running.
Fair enough.
People think ANSP means UTM. And again, the ANSP is an awareness system. It has nothing to do with management.
Are there any questions that we should have asked that you would love to answer, Chris?
Maybe I say yes, and I'm trying not to insult anybody by saying, but yeah, there is one question that I would have asked or I would love to answer. And I've kind of done it in a roundabout way. So I've answered it in spite of the questions, which is, do you think UAS transportation management is the right thing?
Is it?
No. And I think I've been fairly candid about that. What difference does it make what the aircraft is or who's flying it? That is, I think, part of the limiting factor of our conversation here in the United States.
Well, it sounds like we have a lot of topics that we could still uncover and talk about in the upcoming episode. So look forward to having you back at some point. And thanks so much.
Is that an invite right off the bat? Because I usually don't get those. Usually I get, hey, there's the door. Have a nice day.
No, you're always welcome. Thank you so much for being
thank you.
a guest on the podcast. All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.